and I do developer relations for Secret Network. I'm very excited to be doing this demo for you today, where you're going to be learning how to encrypt a cross-chain message from the EVM to Secret Network. So using TEEs, using trusted execution environments on Secret Network, you're going to be able to pass an encrypted string from the EVM. Specifically, we're going to be using Sepolia testnet today, and store that data in a Secret Network smart contract. Let me share my screen and we will dive in. I'm going to try to keep this as short and simple as possible. All right. We're sharing the entire screen. Give me 1 second. Running into a technical difficulty with the new Discord update. All right. There we go. So this is going directly from the Secret Network docs. If you just Google Secret Network docs EVM developer toolkit, you'll see all these different use cases here documented. We have storing encrypted data, sealed bid auctions, confidential voting, VRF, confidential document sharing, cross-chain NFTs, and tokens. Today, what we're going to be learning how to do is just a basic key value store developer tutorial. So very quickly, what we're going to be doing, we're going to be cloning a repo down. We are going to be deploying a smart contract on Secret Network, which we will just walk through very briefly. And then we will send a message using hard hat from our EVM contract to our Secret Network smart contract. Let's dive in. So if you follow along with this tutorial, if you prefer to read rather than to listen to a video, this is probably your go-to bet. It's specifically called the Key Value Store Developer Tutorial. All right, let's get started. So first, I'm just going to clone down this repo. And then I'm going to open it up on my computer in VS Code. So I just cloned down the secret path tutorials repo. There's 5 different tutorials in here, and the one we're looking at today is encrypted payloads. So I'm going to open that up. All right. I'm going to set up our environment variables. So let me see here. I have some test wallets I've already created for us to use today that already have Sepolia testnet funds, so we don't have to go about doing that. So I'm just going to rename this from environment.local to just environment. And let me just pull in these, make sure these are correct. Okay, so this is our MetaMask private key for testnet. And let's make sure that this Infura API endpoint is correct. There we go. All right. So first step is just to set up our environment. We already have Sepolia tokens. We can just install these dependencies. So I'm going to cd into EVM contract. And I am going to install the dependencies. I'm going to open up a second terminal window where I cd into secret contract. And from here, I'm also going to install the dependencies. Oh, actually, cd into node and install the dependencies there. That's just installing secret.js so that we can actually upload our Secret Network smart contract. Okay, great. Our environment should be all configured now. So let's first walk through the secret contract that we're actually going to be interfacing with. And actually, before we do that, let me just give you kind of a high-level overview of what secret path actually is, which is the trustless bridge we're using to send the encrypted data from EVM to secret network. So developers at Secret Network built out a bridge called Secret Path. And if you go to the EVM developer toolkit and to cross-chain messaging, you can learn more about Secret Path here and Secret Network's docs. Essentially what it is it's a privacy-preserving message passing bridge between chains. And what it allows for is public chains, such as Sepolia, which we're using today, to call arbitrary functions on secret network smart contracts while preserving the privacy of the inputs and the validity of the outputs. And this all happens using elliptic curve Diffie-Hellman cryptography. So we have, for every chain we're connected to, we have a public chain that exists, or a public smart contract deployed on that chain that then communicates with the contract on secret, which is the private gateway chain. And you can go into our docs, you can see all the supported networks here on EVM, mainnet, and testnet. So there's quite a bit: Ethereum, Binance, Polygon, Optimism, Arbitrum, the list goes on and on. But we're specifically going to be working with this Ethereum Sepolia gateway address today. And so we actually don't need to deploy a contract on EVM. We just need to deploy a contract on secret. And all that we're doing is packaging the information that we're actually going to be sending to secret in a way that this gateway contract that's already deployed on the EVM can pick up. So that's all that is just like the string, right? And then all of like the ways in which we have to encode and package the information to actually send it to secret. So that's what we're going to learn today, how to do that on EVM. And then we're also going to learn how to deploy a contract on secret that can receive that encrypted data. Okay. So let's go back to the secret contract. Before we upload the contract, let's just take a look at it. So in COS and WASM, in secret contracts, they're usually broken up into these various parts, which is state.rs, message.rs, contract.rs, and lib.rs, library. Library just gives us access to these other three files, super basic. State is where we're actually storing the state of the smart contract. So in this instance, that is the gateway address, gateway hash, and gateway key. So what I was just mentioning about the correct, how there's a private gateway address that exists for secret network, for secret path, we just have to make sure that we instantiate our smart contract with that information so that it has access to that gateway contract on secret, which is what we're going to be doing today. I'll show you that momentarily. And then the other thing we pass to this contract that we store in the contract is the value we actually want to store and the viewing key to view that value. It's the basics of this key value store contract. If we look at the message file, we'll see similarly that we have that instantiate message with the gateway address and the gateway hash, the gateway key. And we have the message, we have the data we're actually passing to the secret contract, which again is just this key value pair. And then we have just some response structs for our query messages when we actually go to query the secret contract. So no need to worry about all of that. It's already ready to go out of the box. You have all this set up to use as a template for a key value store contract on EVM. So let's just deploy, and then contract.rs. This is the actual logic. So we'll see like what we're doing today, we're going to be calling specifically this function, store value. That's what we're going to be calling from EVM. So with our EVM public gateway contract is going to pass this function, store value, which will then communicate with this secret contract to store the data that we pass. So we'll see that if it receives the handle store value, it's going to call this store value function. And in that, we'll see that we store this item in the state, which is the value, the viewing key, and the addresses. And all of this is put into a key map. And then that data is serialized and sent back to the gateway contract. This isn't about doing a deep dive into the contract logic today. I just want you to understand kind of that we have this basic template set up for you. And if you have questions about it or how to make it more customizable, please DM me on on Discord or Telegram at Seanrad, SEANRAD, and I'll help you walk through all the pieces of this. But now let's just actually upload it. So if we go to our upload script, again, this is all set up for you out of the box. It's already configured with the correct gateway address, gateway hash, and gateway public key. And if you want to find all that information, it all exists in Secret Networks docs here at Secret Gateway. So we're doing this for Pulsar for Secret Testnet. And so you can see that gateway contract address, code hash, and ID here, or encryption key here. And if you wanted to do that for mainnet, the only difference is you would do that with these mainnet variables. That's all you'd have to switch out. Okay. Oh, and the only other thing that we need to do is we need to compile this contract. Let's do that really quickly. So the way you can compile a secret contract, you can just run this make script, make build mainnet. Let's compiling our smart contract so that it's an optimized WASM file that we can actually upload to the Secret Network testnet. Wonderful. I'm going to CD back into Node, and now I'm going to run that upload script. So I'm just running this upload file that we already have pre-configured. And it's just going to upload and instantiate that smart contract with the correct gateway contract information. Okay. And that's really all you need to know for working with Secret Path EVM is you just have to configure your upload script on the secret contract so that it points correctly to the private gateway contract on secret, and then you're good to go. You're basically able to use that contract to be compatible with Secret Path. So it returned a code ID, a contract hash, and a contract address. We'll come back to this in a minute. This is actually the contract that we're going to use to pass information from EVM to secret. So let's go back to the EVM contract now. Just make sure we're following along correctly with the docs. So I'm going to go back to this tutorial. All right. So there's a lot of boilerplate code that you need in order to actually correctly package data for the public gateway contract on EVM. So I'm going back into EVM. I am opening up scripts, and I'm opening up this encrypt file, which is what we're about to call. So there's all these imports, everything's already imported. You only need to change 3 lines of code in all of this. The rest of this is all just boilerplate code used to correctly communicate between EVM and Secret Network. It's just formatting data and formatting our encryption message. So all that we need to change here is the contract that we actually want to call in secret. So in this instance, we want to call the contract that we just deployed, right? So I'm navigating to lines 47 and lines 49 of encrypt.js. And I'm just replacing them with the contract hash and contract address of the contract that we just deployed on secret. Okay. Great. And this public client address, this is just the gateway address. So I said we were doing this for Sepolia, right? So if I go back to the docs and we look at the gateway addresses, supported networks, testnet, that's this right here. That's the gateway address. If we wanted to do it for another chain like Scroll, Sepolia, Polygon, Optimism, Base, Tezos, etc., we would use that address. And we have examples in our docs as well, which showcase how to use Wallet Connect so that you can be connected to every single chain that we're deployed on at once. So if you don't want to just do this for one chain, but you want to do it for every single like 30 plus chains that we're connected to, we also have examples that show how to do that. Okay, so this is already configured for Sepolia. We just configured it to correctly communicate with the smart contract on secret that we deployed. And The only other thing that we need to do is make sure that the address we're sending from is the correct address. So let me see what my address is. My address is this address. So I'm using this wallet address. This is the wallet address that is linked to my private key in my environment file. So this is the private key, and the public key is, this is the address linked to that private key. And now we need to see what value we actually want to store. So let's just store the value EVM demo on September 24th, 2024. So this is the encrypted message that we're going to pass. And then these are the viewing keys we're going to use to actually associate with that data that we want to store on secret. That way we can retrieve this value with this key value pair. And so the only other things that you need to know is, remember how I was talking about the handle we call? So this handle is the function name that we actually want to call on secret network. So because it's called store value, what that means is that if we go back into our secret contract and we check out the handles that are available, we see that it's going to call this store value handle, which means it's going to call this store value function. And then from there, we just need to properly make sure we have the correct data that we actually want to pass. So these are the 4 values that we're passing to the secret contract: the key, the value, the viewing key, and the addresses. And you'll see, like, if we go to our store value function, that those are the things that we pull. These are the values that we actually pull from the data that we're passing. We have the value, the viewing key, and the addresses. All right. And that's it. That's all that you need to know. Literally all you need to change is just the value you want to encrypt. Make sure you're using your wallet address, and make sure that you update the contract that you want to call on secret. All the rest of this is boilerplate code. And we can completely abstract this away, which we're actually pushing docs or changes to the docs right now to abstract all of this away. So you're not really needing to see all the other stuff that's going on behind the scenes. It's kind of fun to see it though, if you would like you can just see how we can correctly construct a payload that we're going to be encrypting, the data, the routing info, callback address, et cetera, et cetera. And then we kind of see how the encryption works underneath the hood with MetaMask. But none of that is necessary here. Let's just go ahead and actually call the encrypt function now. So I'm going to go back here, and we can call that by just running, see what it was. Oops. By just running npx hardhat run scripts encrypt.js. And we specifically specify that it's network Sepolia, because that is how we have our hardhat config set up. Right. This is all set up for Sepolia. You could do this on another network that of your choosing, as long as there's a public gateway address deployed on secret. So let's do that. And then we'll see all of our transaction information that is being returned in the console. You can even see the block. You can even see the transaction hash. So if I go to like Sepolia Explorer now, we should see this. Let's look it up. Awesome. We can see all that information. Right, we see the user key, the pub key, routing code hash, the nonce, the callback gas limit, and then the encrypted payload itself. So, but now we can actually go to the secret contract and decrypt this. So let's do that. So I'm going to go back to Node. So now I'm closing this EVM contract folder. I'm opening the secret contract folder. And in my Node folder where I had the upload script, I also have a decrypt script And I just need to make sure that I point it to the correct contract address. So this is the contract we deployed. This code hash. Let's see what our key and our viewing key was, because I already forgot. So we said that our key is, this is my encryption key. And our viewing key is, this is my viewing key. So now using this information, I should be able to retrieve the value that we just stored in the secret contract that we encrypted cross-chain, which is EVM demo on September 24th, 2024. So let us try to decrypt that in the secret contract and see what happens. Is this the correct name? Yes. So I'm just calling this decrypt file now to call this query function. Amazing. And there it is. That's the message we just passed from EVM, from Sequoia testnet to secret network testnet. You can see this value right here, EVM demo on September 24th. And if we change this query at all, if we change our viewing key, for example, it's going to backspace, it should fail. Viewing key incorrect or not found. Now let's just try it with our encryption key. Value for this key not found. All right, I hope that that was helpful. We have, as I said in our docs, examples for storing encrypted data, sealed bid auctions, confidential voting, VRF, confidential document sharing, cross-chain NFTs, tokens, and more. We're really hoping to see EVM developers use this toolkit to build out cross-chain dApps and win prizes from Secret Network. I'm Seanrad on Telegram and on Discord. So if you have any questions whatsoever, just post in the chats or DM me, and I'll love to help you out. Let me just go back to here. Oh, welcome, Return of Lost. We're at the very tail end of this. Do you have any questions about what I was just saying before we conclude today? Nope. Awesome. All right, that is the cross-chain EVM developer tutorial. You now have all the tools you need when you watch back this stream to deploy your own cross-chain contract on Secret Network. And you have the understanding of how to actually package your parameters correctly to be able to pass that data from any EVM chain that we're deployed on to Secret Network. Really looking forward to see what everybody builds. Thanks so much. And please just DM me if you have any questions. Thanks, everybody.